Hello everybody, welcome to MathSpellBook. It's time for us to actually be productive today. Hopefully you guys are having a great week so far. It's Wednesday. It's a Wednesday. In case you're on the other side of the world, it might be like the next day for you or something like that, or maybe you're in a different time zone. So, whatever day it is for you, whatever time it is for you, hopefully you're having a great time at this moment in space and time. So let's get into the study wheel, shall we? All right, so luckily I have my calculator with me this time. I did not forget it. So all I have to do is basically whatever the study wheel rolls into, we'll basically get the book for that, and yeah, we will get into it. So we will interact with the wheel. All right, let's spin the wheel. Wheel of study, turn, turn, turn. Tell us the lesson that we should earn. Oh. Guess we're doing ordinary differential equations again. Okay. It looks like this week the universe just wants me to do differential equations. Because we did physics yesterday and we did differential equations on Monday, so... Okay. That sounds okay. Alright, so luckily I have differential equation books in my file, so I don't have to go skirmaging around for them. Oh, we're already in the textbook section. So, type in different... I think we can do like a textbook that I'm familiar with. Let's see. First course in different... Yeah, here we go. A first course in differential equations with modeling applications by Zill. This is a common textbook. This is usually this one's the which edition? Oh, this is the 9th edition. Okay. So, I mean, I probably should just practice like different techniques because I think with differential equations I made it up to I think like a little bit of first order, but I don't remember all the techniques, so we'll just have to get into it. Okay, so I just want to see what I remember. I don't have a note-taking software, so I have to like actually just like try to remember it. Like I run out of notebooks a lot. Like I sometimes like whenever I try to study like math in general or physics, I use like old notebooks that still have empty pages in them. So we have first order differential equations, direction fields. Let's see if we can find just problems to do. Let's see. Because I never learned about direction fields. I only learned how like solving techniques. Oh, here we go. Separable equations. Yeah, I remember these. I never got up to second differential equations. I probably should like try to like learn up on those. Okay, here we go. Let's do some basic problems. And oops, almost forgot the study timer. There we go. Okay, let's get into it, shall we? And also, guys, if you're tuning in for the first time, you can talk in the chat. You can type up whatever you would like to ask me about or whatever, and I will reply to it when I get to see it. So don't feel like you're bothering me or anything. I am just basically just... This is like more like a hobby for me. So this is like no different than me just like on the computer looking for YouTube videos while you're probably just chilling like wherever you are, and like you just want to like ask me a question, go ahead and ask me a question, and I will do my best to try to answer it. Or like, if you just want to start a conversation, that is also fine. Because I think it's like this is like I'm like totally different when it comes to like productive streams. Like I usually think of it as like we're like in like the office, or like Maybe like somewhere where we're just like by ourselves and we're just like doing our own thing, but we're also able to talk at the same time. Okay, so solve the differential equation by separation of variables. Seems simple enough. So, boom. We multiply that. And then we take the integral of this. I actually have to rework on my integration techniques. So this is 5. So du dx, that would equal dx is equal to du under 5. Perfect. And then when we integrate y, we are then given the cosine, the negative cosine actually, of 5x over 5 plus c. Perfect. I believe that is the correct answer. Because, yeah, the integration... I almost forgot the negative sign there, so not a problem. Let's go to number 2, shall we? Okay, so I don't like this mess over here, so I think we're just gonna like clean it up a bit. There we go. That looks much nicer. Don't you agree, guys? See, like if the math doesn't look nicer, it doesn't look like something, if it looks too scary, just basically turn it into something that looks less scary. Okay, I just wanted to make sure, like, because sometimes, like, when I think a problem is simple, sometimes it turns out to be a little bit more tricky than I thought. But luckily, I don't think we see some surprises there. So, to the third. Actually, my handwriting is a little bit better than it was last time. X, yeah, because then when this turns into x squared, there will have to be a 2 there, so we'll get rid of the 2. Okay, so I'm not wrong there. C. Okay, so we don't have to do anything to y because y is just by itself. Cool. So this looks correct. If anything's wrong and I say it's correct, guys, correct me, please. Ooh, this one looks a little bit more interesting. Let's just tackle this. Okay. All right. Okay. I see where this is going. Okay, so we have a couple options here. Couple options. I could... Either way, I will end up with what I want, so... What I think I'll do is that I'll just leave the dx... no, actually that wouldn't look nice. I think we'll just minus the dx. Make it easier for ourselves. Easier on the eyes. And then we'll just touch it up here. And then we'll divide that. Give us negative dx. Oops, I don't like the way that 3 is. Hopefully you guys can see that. Yeah, but that 3 looks too tiny. I want to make sure that you guys see every part. Okay. So, now we integrate. Or, actually, we can make this look a little bit nicer. We can do this dx with the little negative sign. Let's not forget the negative sign, because I always do that. So, we'll integrate both sides. We'll just put the negative sign in front here. And... yeah. Okay. Now we'll just end up with y, then x. Okay, so, well actually, first, before we do that, before we actually do the finito, we're gonna do this, and then du dx, and then dx will equate to du -3. Okay, so now I think we'll just move our problem up here, make things easier, so that way we don't have to scroll down. So we're left with y equals negative the integral of u. Right, so then we can move the 1/3 there, and the negatives annihilate each other, so we're just left with this. And then we're just left with EU. Well, technically it's like this, but and then, but this is also negative, so we have to remember that. And I'm pretty sure the C will absorb the 1/3 here. So it will be 1/3. And I'm pretty sure that is the answer. Okay, I think time to scroll down here. I'll probably do like five of these type of problems, and then I'll probably try to move on to like maybe a different set. Let's not go in order though, because I think it's like, I think we already got a hang of like, I think the simpler ones. Let's try something that looks a little bit more messy, because I actually have to challenge myself. So number 9 looks a little bit interesting. Let's tackle that. dy. Oops. Was it dy dx? Ooh, yeah, that looks a little bit interesting here. So we're gonna have to mess with this a lot. Hopefully it's not too much that I can chew. Okay. All right. So we got well, let's just touch up on the top first, because this is no different than this. So what we can do, multiply this here, yeah, and then there's a y here, so then we'll multiply 2 squared here, and then we will divide, we'll divide y on both sides here. Okay, then let's just erase that y, because I don't like how sketchy it looks. Sketchy. Okay, so both sides are like separated by their variables. Actually, let's clean up this y, y plus 1 to squared, right? That over y, and I think we can clean it up a little bit. Yeah, we can definitely clean it up a bit. So I think I'll just move it up here. So squared. So take away y there, and then y there, and then we have y over 1 there. So now we have like, dang, I think we're gonna have to do integration by parts, like for the x part. I mean, I don't hate it, it's just that there are times when I feel like I just don't want to do that. The thing is that we end up with a lot of Y's on the other side too. That's the one thing. Unless this equation doesn't require you to solve for like y, just to basically just integrate it all. Because there are some problems like that. But this is good because it actually challenges me to think a little bit. Because the thing with me is that when I do math, I try to get everything done, and I try to basically like, oh, that's automatic for me to do. But now I actually have to think. I have to think like, what is the next, like, not only what is the next step, but what does that step lead to? Okay. I'll just try integrating one side at a time, see where it leads. So I want to put this over here because I don't like the way how that 2 is like stuck in the middle. Doesn't look nice. So for y, we'll just bring this down here, and then it'll be y squared. And then, oops, natural log, it's not an h. And then, oh, nope, not x, y. We want y there. And we're not going to put the c there because we usually put the c at the end of the x ones. Yeah, I don't think there's any way for you to properly separate y as far as I'm concerned. Yeah, I don't think there's any way you could separate y. Okay, so now we have a couple choices. We could either do this by just integration by parts, or we can do this with tabular technique. Let's see, if we do it with tabular, it's not hard. So it's plus, minus, plus. So we're going to differentiate this one, and then we're going to integrate this one. So this would end up like this. This would end up like this. But then again, you don't end, because usually you want one side to end. So I think we're just gonna do like the hard approach. We're just gonna do integration by parts. Yeah, because tabular works if like one of them actually not converges, but like actually like reduces all the way up to 0. And usually that's like the differentiation part. Because I don't want to integrate the natural log, because that's going to be like a lot more cumbersome than it's worth. Okay, so I think we will differentiate this one, the x, and then dv, meaning that v is, yeah, okay. So now we do the hard part, putting all these together. Square, right, minus, okay, d, oh, we're gonna integrate that anyway. Wait. Hold on, I can rewrite this. So let's just say, boom, boom, boom. I think I see something. I mean, I could be totally wrong, which is usually the case, but do that minus, and then we end up with the same exact thing. I remember encountering this problem a lot when I was taking Calc 2. I always thought that was the coolest trick. Yeah, because it ends up the same. Yeah, because yeah, that's what we want. Yeah, so perfect. That actually makes it a lot easier. And then plus that. Oh, that's beautiful. I actually love this trick. Actually, this trick was like, when I first saw this trick, I was like, that is so cool. And then we get 2 of these. And then we just divide by 2. Well, technically on like that, including C, but the C is just going to absorb it anyway. So then we get... Wow, this problem is really, really, really a lot. So in general, we are left with, wow, this problem is like wowzers. It's just straight up wowzers. I mean, hopefully it's right. Oops, not X, not X. And if it's wrong, then, you know, I will accept defeat and I will basically say, hey, it's wrong. But, you know, I'm pretty sure the book has a better formulation. Actually, I'm going to check the book, see what the answer is. So this is 2.2. So 2.2, oh, I should look at what number it is before I do stuff. Oh, actually, did I write the number down? I think it was 9. Yeah, it was 9. Okay. So 2.2. Oh, 2.2. Here it is. Here it is. 2.2. Number 9. Okay. Oh, oops. I forgot those. Always remember to put those. Let's take a look. Okay, the y side looks correct from the textbook. Hold on, I want to make sure I didn't miss anything. Because the way the x side looks, I want to make sure I didn't. Maybe I messed up somewhere on the x. Yeah, I think I messed up somewhere on the x side, because it says that the x side is like 3. I probably totally missed something, which usually happens. I think this is the reason why I hated math like in school, because I would miss something and I would be like, dang, I lost points because I missed one step. They say that the x part should look like this. Okay, there's something I missed. Yeah, there's something I missed here. What did I miss? Because I'm trying to look right here. Because we did, integration by parts, so right. So yeah, that is in the answer we got. Yeah, so we took, yeah, it's supposed to be x squared. Let me take a look at what the problem looked like. So yeah, the problem looked like this. Then we divided by y. Ooh. So the y part we got is right. So I don't think we did anything wrong with the y. Where did I miss? What did I miss here? I must have missed something integrating the x part. The question is, what did I miss though? So we integrate, so yeah, we put these two parts together, minus, and then we got but the same result. Yeah, because it's supposed to be u with dv. Yeah, and it's about practically the same. It's like basically you add this side, get 2 of this. Let me just erase that part here. Yeah, you would get 2 of those, and then you can just divide 2 into... I wonder how they got this answer. Because I feel like I did everything right here. That's gonna eat away at me. I feel like I did everything right here. Huh. Because I wonder how they got this. Maybe I did I didn't do a step? Which usually happens. I sometimes don't do a step. Because both results, I mean, yeah, because like I think I did everything right here. Huh. Maybe. I'll post this on YouTube, and if you guys see the mistake I did, you can leave it in the comments down below. Because honestly, like I don't want to assume that I'm always right or anything like that, but I feel as if like I did everything that I could see is, I guess, proper procedure, but then again, I could have missed a step. So if I missed something, you guys can let me know once I upload this on YouTube, or like if you're in the chat right now, you can probably like let me know. But I feel like I did everything right in this step here. Because I mean, I got the y part right. It's just this part, I don't understand what I missed. Huh. Oh, okay. I think I see what I did wrong. Okay. See, this is the reason why, like, I basically, because it's supposed to be, I think, v and dv, du. Okay, that's what I missed. Okay, I wrote the wrong thing. Okay, that's what I got wrong. Okay. I think now I see it. Because I thought it was supposed to be u and dv, but I mixed it up. Okay, so that's what it's supposed to be. Okay. Luckily, I remember. Luckily, I suddenly had that struck. So it's supposed to be... Okay, now I get it. Dx. Okay, so that's what it's supposed to be. Okay, that's what I missed. Okay. See, like, this is why I have to rework everything from, like, Calc 2, because I think I remember it, but then I really don't. Okay, so it's not supposed to be that answer. Okay, so I was wrong. I was totally wrong. But luckily, I found my mistake. Yeah, so then, yeah, that would be like 9, and then like that. Yeah, and then we'll put the C here, like we did last time. Okay, so now we got the correct answer. So that's why it's the answers like that. Okay, now I understand now. and that's equal to y. See, like, the thing of it is that I don't try to prove that I am an expert at math, actually. In fact, when I look at people that I've met in the math space, like, they're like way more brilliant than I am. Which is probably saying, like, well, I don't want to sound like pompous or anything, because I don't want to say the wrong thing, because I want to say that they're really smarter than me, but then again, like, to be smarter than me is not a big challenge. That's what I really wanted to say. Anyone could be smarter than me. In fact, I assume that everybody is smarter than me. That's my assumption. I usually assume that everybody knows a lot more things than I do. Okay, that problem was actually pretty interesting. Okay, so that was a pretty good one. That was a pretty good one, because I actually got it wrong before, but then I saw my mistake and I saw what I did wrong. So it's really working up the math muscles. So now I'm getting, like, I actually remember integration by parts much better now because of that. Okay, let's try another tough one. Number 10 looks fun, but we don't have an answer for that, but we'll try to work our way to see if we do it right. So let's challenge ourselves, shall we? Let's challenge ourselves. I find it funny that we got, like, ordinary differential equations twice on the wheel. I thought it would give us something, like, different, but, you know, the universe is basically just spoken. So okay, so first we shall multiply that to that side. Yeah. And of course we would divide that from that side, so okay. I'm just like, that 4 didn't look nice. Well, then again, like, whenever I write very fast. Okay, so I think we're just gonna clean this up a bit, but we got, like, some constants in the beginning, so that's gonna be fun to clean up. So let's just do it the old-fashioned way. Write it all out, so we don't have to think too much trying to visualize everything. So dun 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 dun. That's 6. That's 6. So 12. And then dun 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 9. Okay, and let's do the other part just so we can get it out of the way. Get the algebra out of the way first. So then we get 16 10, to x squared, 20, so then we get 40, and then 25. Cool. So then we're left with, yeah, so it's gonna be like that anyway, so we'll move everything over here. So we are left with dy over 4y plus 12y plus 9 equals dx over 16x squared plus 40x plus 25. Okay. Now the hard part. Making them all work. Oh. No, that wouldn't work. I was thinking of u substitution, but I'm like, no. U substitution wouldn't work. Because we would have too many variables. Let's see, we got, like, polynomials on the bottom. Unless I'm supposed to use unless there's a trig identity integral that I have to think about. Maybe I shouldn't have maybe I shouldn't have foiled them. Yeah, this is why I have to do more math problems, because the simplest ones I would get like off the bat, but then like when it comes to the ones that involve a little bit more recall, this is when I get a little bit flustered. Because usually whenever I get a math problem, when I get stuck on a math problem, it's usually a part where it's like there's got to be some trick to it. Like there's like a trick there. And I always forget the tricks. I always forget the small little tricks that people would do. And there are times when I would overlook something, and then I would see like, oh, you can convert this into this. It's usually like those things where I have to think of it as a different type of object. Huh. But what must I do here? Should I have left it 2 squared? I mean, like, should I have left it in its square form? I know that there's some way to solve this. It's not coming to me. What am I missing? I'm missing something. I'm pretty sure I gotta remember, what was it that you needed to do to solve a polynomial in the denominator when it comes to integration? But I don't remember what it was. I guess we'll skip it for now. I mean, maybe we won't get back to it, but you know, if anyone like has any idea of what I'm missing, like if you're watching this on YouTube, like, you know, put it in the comments down below. If you're on Twitch with me right now, like, you know, if you want to give me a hint, you can give me a hint. But I think we'll skip it for now and let my brain like just like work on another problem. Maybe it'll come to me when I'm working on this next problem. All right, so what do we do? I get a feeling 11 is just going to be just as hard, because it looks complicated. Like, I'm giving myself hard problems so I don't like skimper out on myself, like, of my own learning as well, because this will allow me to actually do like basic recall. Okay. Oh, we got another like funny mix problem. So I think we'll minus the x side. And then, well, technically they're all mixed up, so we're gonna end up with and then fx. Ooh, actually, I want to move the negative on the other side. Actually, this is kind of good for us in general, because now you get to see where I'm actually having blind spots. Whether we come back to this or not, like, you know, it's up, I guess it's like up for debate, I guess. Okay. So that's not squared. Okay, cool. So if let's try integrating it, because when I think of this, I think of like sine, well, it should be sine y actually. Sine y. Well, actually, if you wrote it like this, I'm just trying to visualize it better so I can see the process and without having to imagine too much. So if it's like that, then we can rewrite it as, because then it will be sine. Oh no, not like that. Like this. Sine of y, which in turn will turn into negative cosine. Okay. Let's just move this up here. So we got negative cosine of y equals negative. Let's write this as 1 over cosine of x, which in turn we can flip it over. If I'm totally wrong about this, like, you guys can just let me know in the comments. That's not how that works. You can just type it in the comments. It's like, that's not the way it works. It's just me trying to be like clever and like trying to make it simpler for myself to see. And I think we can rewrite this as now I'm trying to remember. I think with cosine it's plus cosine the square root 2 half. I think. I don't remember. I mean, I hope I'm right, because I think with sine it's minus. I mean, that is my assumption. Oh, actually we can get rid of the negative sign, actually. Because we can just get rid of it. And then we can move that half in front. So we're left with cosine. What's that? Alright. So then cosine a half. Oops. No. The half should be in front here. And then we're left with dx plus cosine of the second. Well, cosine of 2x, I should say, not the second. Cosine. So that would be left with x plus, we'll just write this here so that we can do the work properly. And then it's like 2x, then 2x. But if you want to write it with just dx, it will be du. And then we'll move this again up here. So we're left with cosine y is a half times x plus, we'll move the half out with cosine of u du. Hopefully I'm not moving too much off the board, but I don't think I am. Wow, my DUs are looking very bad. I think it's because it's almost at the edge of the tablet. That's why it doesn't look that great. Okay, cosine of y times x plus a half. The sine of, well, we can put back 2x here. and then plus a C. I mean, hopefully this is the answer, because I had to actually think a little bit back to trig identities for this. That's what I'm hoping. And also with this cosine here. So I think we can put the half into where it can be. So 4 sine the second. And I think the C is just fine the way it is. Now, the tricky part is that we have to do all this cosine of all this nonsense. Oh, why did I put 4? Shouldn't be 4. Plus C. And I believe that is the answer. I mean, hopefully. Is this an odd number? It is. So it's 11. So we can actually take a look. So it's 11, 2.2. So hopefully it's the right one. They had a different answer. I guess I have to learn what I did wrong here. Because the way they wrote it is like this. Maybe I wasn't clever enough, huh? I mean, let's see. Let me see if I did everything right here. So this side, yeah. So this side is, yeah. I think this side is correct. Yeah, because then we got the negative from the cosine of the. Okay, so the negative is right, and us like taking away that negative sign makes it easier. Yeah, so we were correct at that side. Well, I don't mean to say we. I should have said I, but you know, you guys are here with me on the problem, so we're like researchers trying to solve the basic stuff. Okay, so maybe I didn't get the identity right here, because maybe cosine is minus, right? No, I don't think so, because there's a plus sign here. So maybe we did that right. Because this is supposed to be the correct answer. Oh, and we're out of time. Well, that was a pretty productive study session. We got 2 problems practically incorrect. I mean, I'm not mad at that. It's just that, you know, obviously I want to get the question right to see that I was on the right approach, but unfortunately I guess I misstepped somewhere. But yeah, I'm pretty sure that's probably like a good way to actually like give myself a little bit more I guess foresight into like seeing what is it that I'm doing wrong or what is it that I'm lacking when it comes to my mathematical abilities. But yeah, so I think we're just gonna end stream here because I do have to stream on my other channel, and if you want to check out my other channel, I will put the link in the chat. So If you want to check out my Uncle Talks Twitch channel, you're more than happy to do so. I'm planning to play like Honkai Star Rail there, and also like, you know, I will like also be chatting with you guys there on the long end as well, because I'm actually going to play the story of Honkai Star Rail, and I think it's a story update, or it could be a character update. I don't remember exactly, because they did maintenance yesterday and I haven't played it, so I'm pretty excited about that. But yeah, like, so if you're watching this on YouTube, let me know in the comments what I got wrong on these two particular problems, because sometimes I try to do some, like, I guess things that I think are clever, and they could end up like just blowing up on my face, and I totally mess up on the problems. But you know, if you think that I got the problems right and maybe the answer in the book is just kind of iffy, you can also let me know that as well. But more likely it's probably something I did wrong and I just didn't see it at the time of like actually doing the stream. So yeah, so I think that will probably do it for today. I'm probably not going to chat like the whole entire break time, because obviously I got to stream like a little bit later today, so on my other channel, so you're free to check out my other channel. And if you want to check out my YouTube channel for MathSpellBook, you can check out the YouTube channel, like if you want to catch up with that. So basically the YouTube channel is like my own personal diary to basically show that what I got wrong, and like, you know, what I'm going to do in my own mathematical journey as well, because like I look at math as like, I guess, my own hobby, because there's no way I'm going to be able to you know, do the typical traditional approach where you basically like go back to school and do a PhD or something like that. For me, I would see myself going back to school to get a bachelor's and in math and physics, but I don't see myself getting a PhD, because obviously like when you get like to a PhD level, they expect you to be extremely brilliant and get like, you know, arithmetic down and like all those other things really, really fast. So I know I am not in that ballpark, but at the same time, like I would like to like, you know, talk to people that are actually in those fields and like be able to like learn from them and actually be able to like, you know, take the slow approach to solve problems. Because for them, I'm pretty sure like they can have their brain on hyperdrive and they're actually able to see a lot of more stuff than I do. For me, I just like looking at the equations and just like messing around with them and stuff. Because it's kind of fun, because when you actually look at like, you know, a board of equations and you try to make sense of a mess, and most people look at equations as a mess, I feel as if like there's like something there that is like kind of like telling you that there's got to be something within it that's telling you some sort of truth about the problem in general. And you know, math is like, you can use math to apply to like, you know, problems in real life, or they can just be curiosities that you just basically took from a book and you basically like, I think this is cool, I want to actually try to solve this problem. And sometimes the problems just intrigue you so much that you end up developing your own branch of mathematics because of that said problem, you know. But thank you guys for chilling with me today. I know this stream was a bit short, but at the same time, like, we got some differential equations done, we challenged ourselves, and that's the most important thing. When I challenged myself, I saw that I have a little bit of brick walls that I have to get through, so that is a good lesson for not only me but also for you guys as well, because like, you know, even though I am not great at math, I still love the subject. And you know, I've seen a lot of like math like content creators like create like content that go way above my head, and I don't fear that. I feel like I'm inspired to actually try to get to their level, even though like their level is probably like just a bachelor's degree in mathematics. But you know, like the amount of knowledge they gain from that subject, like that time they did at university, like making proofs and all that stuff, I think that's very inspiring. And I really want to get to that level where I can actually just study on my own and like read a proofs book on my own and like try to play around with the math. Just like, you know, like I want to learn physics so I can just play around with like, I guess, like equations that are in those books, just to see what will happen. But yeah, so that will be it for today, guys. And like I say on my second channel, always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys in, I'm not sure if I'm going to be streaming tomorrow on this channel. Probably I'll not stream tomorrow for this channel, but I will probably like try to stream like the days after that. So, no promises. So like I would have to say, like, don't expect the stream to be coming on tomorrow, but on Friday and Saturday and Sunday, I would say like Friday and Saturday and Sunday probably I won't be streaming. I'll probably just make this like from Monday, Tuesday, Wednesday type of thing, because I also stream on my other channel Monday, Wednesday, and Saturday. So I don't want to tire myself too much with like streaming on 2 channels. But yeah, so I will see you guys on the wayside. So take care, guys. Bye-bye.